Hello boys and girls, this is Daniel for Rock the JVM, and in this video I'm going to talk about Scala 3, and in particular about the indentation syntax that's going to come in the next major Scala version. Now, as prerequisites for this video, I assume that you already know the existing Scala syntax, namely Scala 2, and optionally that you are probably concerned about the introduction of this new significant indentation syntax. You may be worried about Scala becoming the next Python or similar other questions. We will take a structured approach in this video, and we will show how that is not the case. And as always, I'll recommend that you code with me in this video, and whenever you need to refresh your memory about these concepts or about the elements that we're going to discuss, just refer back to this video or to its written form at the blog with the link in the description. So let me get back to my code editor, and I have here a small Dotty application that I've built with IntelliJ IDEA. So in the latest version of IntelliJ IDEA, you have the experimental support for Dotty, which is the pre-Scala 3.0 release. You can go to File, New Project if you want to create one of these projects yourself, and you can select Scala on the left-hand side if you have the Scala plugin installed, and Dotty here on the right-hand side. And then you can follow the rest of the wizard steps as if you would on a Scala 2.0 project. And here I have a plain object with a main method just in case we need to test anything. Cool. So regardless of whether you're experienced or new to Scala, you've probably been confused about Scala syntax inconsistencies and potentially many alternatives at least once. And in this video, we'll take a very careful and structured approach at how Scala 3 adds yet another facility to our ever-expanding set of alternative code styles, which is significant indentation. And I'm going to start with if expressions. So the Scala 2 syntax allows you to write if expressions on multiple lines and in multiple styles. And the aesthetics of if expressions are generally along the lines of, let me define a val, let's call this a condition, as, let's say, if 2 bigger than 3, then I'm going to return the string bigger, else smaller. All right, so this is the kind of one-liner style. There's also the Java style, which is with braces on every branch. So if I define, let's call this a condition 2, I'm going to say if 2 bigger than 3, then I'm going to open a brace, and then I'm going to return bigger or some code block, else I'm going to open another set of braces, and I'm going to return smaller. And yet another alternative style, I'm going to call this compact. I'm going to say val a condition 3, and I'm going to say if, let me add another tab here, if 2 bigger than 3, and then I'm going to say bigger here on the if branch, and otherwise I'm going to return smaller here. All right, so these are some of the alternative styles that you can write if expressions in. Now, to be clear, all of these are still supported in Scala 3, and this is the case because I am in a Scala 3 project. However, we can make do without the braces here in the Java style notation, and even the parentheses of if expressions, while indentation becomes significant in this case. So the rule is that when you remove the parentheses around the condition of the if clause, indentation becomes significant for this expression. This means that the else branch needs to be at least at the same tab level, at the same indent level as the if branch. So I would write something along the lines of a condition, and let's call this a condition 4, and I would write this as if 2 bigger than 3. Notice that I haven't added any parentheses. I would say on a tab bigger, and at the same indentation as the if branch, I would add another tab and I would say smaller. Now, why was this significant indentation introduced for if expressions? In real life, mixed indentations for the if-else clauses in the Scala 2 style were extremely confusing, especially in junior code or in hacked code. So if you had lots and lots of if expressions, you've probably seen your fair share of if-else chains that are very, very hard to read because they are not in the correct places. But in this case, with significant indentation, the compiler is now responsible for flagging out errors if the indentation is not correct, so that you are forced to follow the correct indentation style. So this is something that the responsibility has shifted in the direction of the compiler this time around. So the code looks something like this, and in my opinion, the code also looks a bit cleaner than the Java style version with all these braces. It's hard to read what every brace does. Now, you can still remove the parentheses around the condition of the if clause and still follow the one-liner style, but you would need to add another token here. So I would say, let's call this Scala 3 one-liner. So if I would say a condition 5, I would say if 2 bigger than 3, then bigger, else smaller. So notice this then token here, which is a boundary between the condition and the returned expression of the branch. This then token allows you then to use the compact form of the condition. So I'm going to simply copy that. I'm going to paste it here, and I'm going to call this Scala 3 compact. And I'm going to name this a condition 6, and I can remove the parentheses. And I will introduce the then token here, which also makes this expression look a little bit more readable. So you would say the value of a condition 5 is, well, if 2 bigger than 3, then it's bigger, otherwise it's smaller, right? So this looks very similar to natural language. So this is the if expression, significant indentation in Scala 3. If you remove the parentheses, indentation becomes significant, and significant means that the else branch must be at least at the indentation level of the if. So if I try to put it, for example, here at an inferior indentation level, the compiler says end of statement expected but else found, meaning that this else is taken out of context. All right. So the compiler just finds the end of the expression here and does not find anything else at the same indentation level. So the expression is still considered this. Okay, now this else branch needs to stay at the same indentation level as the if. This is basically it with if expression. There's nothing rocket science. If you remove the parentheses, indentation becomes significant. Keep that in mind, and the compiler will force you to write a little bit more readable code. The second thing that I'm going to talk about is for comprehensions, because a similar change has been added to other control structures like for comprehensions and while loops. Now, the idea is that if you don't add braces to those, indentation becomes significant, much as the if statements here. So here's what we used to write. So in Scala 2, we used to write, for example, for, and then we would open some curly braces here, and I would say for a number in a list 1, 2, 3, and the character in the list A, B, and C, I would yield a string, for example, a character, and then the number. All right. For example, A1, A2, A3, B1, B2, B3, and so on and so forth. Okay. So we would write for comprehensions with these braces to delimit the generators inside. Now in Scala 3, there's also the accepted syntax that you can write for and then without the brace, but in this case, indentation becomes significant, so you would add the generators at the same indentation level, so you would write something like this, and at the same indentation level as the for, you would say yield, and I would add this expression over here. So this is now the acceptable syntax with Scala 3 if you don't add braces here. And the indentation becomes significant here in the sense that the generators and the yield part of the expression must have the at least the same indentation as the for. Let me give an example of some unacceptable code. So if I write a variable here, if I define a value, let's call this a comprehension. And then I would type in an enter here. These generators must have at least the same indentation as the for. If I put them on the left-hand side of the for at an inferior indentation level, the compiler is now confused. All right, so I'm going to remove that. In this particular statement, the indentation level of the for comprehension is 0 in this case because there's just white space before the for comprehension and there's nothing at a superior indentation level above. All right, so the indentation level is actually this one as inferred by the compiler. The compiler does a lot of things behind the scenes to validate the indentation level of a expression. And other than that, there's nothing rocket science with for comprehensions either. You can simply omit the braces and just keep track of the indentations of the generators. Now, the third thing that I'm going to talk about is indentation regions. This is a potentially confusing and complicated topic because the compiler does some stuff behind the scenes that we are not aware of, and it's worth being aware of that. So in the syntactic analysis compilation step, the compiler will add some indentation regions after certain tokens. In other words, after keywords such as for or if, the compiler will add some fake tokens at the break of the line, so at this particular point, here that is, the compiler adds a token that's called indent. And this indent is a signal to the compiler that it expects some structures that are indented at least at the previous level. So the generators must not be at an inferior indentation level. And the compiler does that by adding these fake tokens at the break of a line after certain tokens, such as for. Okay. Now, the effect of that is that methods can be implemented without braces. So here's an example. I'm going to define a method called, let's call this compute meaning of life. I have something with a meaning of life, and I'm going to pass in some kind of argument, and I'm going to return an int. And on the right hand side of equals, I'm going to break, and the compiler will add an indentation here. And at a superior indentation level, I'm going to print something like computing. And after a few lines, I'm going to add the line 42. Notice that the compiler has added braces here to make the code clearer, but I can remove them. So I can say something like this, and this code would be the implementation of this method. And that is because the number 42 is at the same indentation level that the compiler expects after this break, after the equals. If the compiler sees something that at an inferior level, like print line something, and then I would say 45, this 45 would not do anything because it's at an indentation level that's inferior to what the compiler expects after the break. So these two will be simply executed as the body of this object that I called indentation, as the body of this application. So these I can remove, and the implementation of compute meaning of life is this whole highlighted block. And just to prove that, I'm going to print line compute meaning of life, and we are in the year 2020, where many people are wondering what the meaning of life is, and I'm going to simply run this just to prove that we are going to print 42 here because that's the returned value of this method. So in this case, it's as if the compiler automatically added some imaginary braces at the beginning of the implementation, right after the equal sign, and right after the last line with the same indentation level as what the compiler expected, in this case the number 42. And if I added some braces here and added one at the beginning of the method, this is what the compiler actually does for us behind the scenes. But it's really hard to read that this method actually does something. And notice that IntelliJ has somehow moved my code, and right now the print line and the 42 are not part of the method anymore, so I need to indent them again. Now, I personally find this part particularly confusing and or frustrating because the number 42 doesn't really look like it's part of the method, right? But the compiler sees it as such. And so if you have some really long white spaces here, it's particularly confusing to read the code. And so the code style suggestion that I will make is that whenever you have either long methods or significant white space, like line breaks inside your method implementations, you should simply add code blocks. So add braces for visibility. All right. So in this case, the number 42 is now clearly part of the method, and what is in between is just white space. Now, an indentation region, which is what you saw here, can also be manually introduced by the colon token. So if I defined a class, let's call this animal, and put a colon at the end of this and then broke the line, then the compiler will naturally start an indentation What I mean is that the body of this class will need to have this indentation of my cursor over here. So if I define a method called eat, and I define it as unit and just implement it as question marks, this is the body of a class. So the colon over here, it's as if you started a brace, and then whenever the compiler sees a line with an inferior indentation, it will simply close the body of that class. And this is the same for classes, traits, objects, and enums, for which we have a dedicated video here on the Rock the JVM channel. All right. Now, similar rules will apply for extension methods and given instances, and we'll talk about those in a later video. So if I write, for example, a given instance, I will say given my order as ordering int. This is similar to implicits, and I will add a colon over here. Then the def compare of this ordering, I will say x int and y int, and I will simply return x minus y. I don't really care about that. The colon here will start an indentation region, and whenever you write below at a superior indentation level is taken by the compiler as the body of the anonymous instantiation of ordering. Now, for the $1 million indentation question, should you indent with spaces or should you indent with tabs? Now, obviously, Scala 3 supports both, and the compiler is able to compare indentations for 2 consecutive lines. Now, I will give more details in the article because it's really hard to compare them on video and I don't want to bore you. But the bottom line is just don't mix spaces with tabs, all right? Just pick one, either spaces or tabs, pick your camp, fight to the death, create memes until you're bored to death, but just don't mix spaces with tabs because you'll confuse the compiler. So that's that. And the final thing that I want to show you is calling methods with one argument. So in Scala 2, we used to write things like a future is future, the apply factory method, and then we used to open and close some curly braces, and this block of code is the argument to the apply method of the future companion object, and I would put in some value here. Now, the execution context here probably prevents me from properly compiling my code, so I'm going to import Scala concurrent execution context implicits global. Not that I would ever want to use it myself, but just to make the code compile. We do write these kinds of structures in real life. So whenever we have a single argument apply method from some type like future or try or option or things along those lines, or simple methods from functions like, let's call this processed list, and I would say list123.map, and I would add a pair of curly braces, and I would say x arrow, and then you would implement the lambda here, so you would say x plus 1 or things along those lines. So these kinds of structures where you call a method and the only argument of that method is in between curly braces, in Scala 3 you can also omit that. So you can remove the curly braces and you would add significant indentation. However, this is not baked into the language yet. So you would have to go to your build SBT, or you would need to pass the compiler option here. So you would say Scala C options in a sequence, and you would add the compiler option to say -y indent colons. And -y indent colons will allow you to write colons in the style that we described earlier with the start of an indentation region. So you would say something like future and then remove the curly braces, and you would say future colon, and in an indentation region you would write whatever you like. So you would print line hello future, and finally return 42 here in this imaginary code block. So this code that I've highlighted here on screen is an indentation region which acts like a code block. And so with a colon here, you can add an indentation region. And in the case of a map, you can also write something like list123.map colon, and then on another line in an indented fashion, you would write your lambda. So x arrow, and then another indentation region, and then you would implement that lambda, like print line processing, and you would inject X, for example. And these two lines, line 74 and 75, is the implementation of this lambda, and this whole indentation region is the argument to the map method. All right, so you can try to be consistent with the other colons at the start of indentation regions by passing this new Scala C compiler option -y indent colons. So I hope that makes sense. And finally, to end this video, I'm going to end with a pun, because Scala 3 has introduced an AND token for when you want to make more sense out of indentation regions. So for example, if you define a class that has lots and lots and lots of code with lots of white space in between, it's hard to keep track of which indentations belong to which pieces of code. And so Scala 3 introduced the AND token, which you can use to mark the end of a block of definitions. So for example, for the class animal, you can say AND animal. And you can add AND tokens to methods, to if statements, to for comprehensions, and to methods. So for example, if you define the method eat as, and with an indentation you would print line eating or something like that, you could, at the same indentation level as the definition, you could add an AND token, so you could say AND eat. So you would use something like that, and then AND animal. Now, IntelliJ is not really up to speed yet with Dotty syntax highlighting, but I'm pretty sure the development environments will catch up. So as I mentioned, you could use an AND token to AND if, for, while, and so on, and so on. Methods, classes, traits, enums, objects, just to name a few. I think these are most of the situations. So that's it. That's basically all you need to know about indentation, significant indentation in Scala 3. I hope this video was useful, in which case I will ask you to please click the like button for me and subscribe to the Rock the JVM channel for more videos like this. And follow us on Twitter and LinkedIn for fresh updates on upcoming material. As always, I'm dying for feedback, so please leave your comments. I read every single one. And check out the Rock the JVM website. We have tons of video content on Scala, Akka, and Apache Spark, and more is incoming. Until next time, I'm Daniel, signing off.